the temperature drops, and we may hypothesize that the middle portion will start to crystallize. And here is the idea that we have proponents in this group of that idea that universe ether is crystallic lattice. Now, I came to that by, I'm an engineer, I do some patents and gravity machines, and I got a US patent for a machine that manipulates the lattice of the vacuum. It's not important, it's only important why I started to work on that. And I found that, no, I'm not a founder of the proposal. Crystallic lattice idea was formulated by Professor Menachem Symphony, which is to the right of me here, and he modeled the crystal lattice of the vacuum with electrons and positrons in the manner of iodine sulfur crystal. And then I started to think whether the system like that would reflect the world that we observe. And I came to a conclusion that there are some problems there. One is crystal of salt is brittle and it's solid. Imagine just a single crystal. It's polycrystal. It has certain qualities that do not relate to the universe as we see it. We see in the universe that, first of all, we have small variation in temperature. Yesterday we discussed that the temperature of the Wilkinson probe shows the microwave variation, but the temperature is very close. It's close, but it's not the same. If we have a crystal, we would have the temperature equalizing because of the entropy. So we do have here some variations, and we do have, of course, the motion of galaxies that run away, expand, and the rate of there is an acceleration in expansion rate. So we see that the crystal static model is not very, there are problems with that. So the next, when we see a Dirac Sea, let's say we have a Dirac Sea of electrons and positrons, and we have a crystal isle in the middle. And when electrons and positrons collide, and they would collide, there is a process of annihilation, and what we see is two Majorana particles flying away. One is plus, one is with minus sign. Why? They don't annihilate each other because they have the same, they have a repulsion force. Anyway, this is a Torre Majorana. He formulated the particles well before neutrinos, electron neutrinos, which are typical Majorana particles, were discovered. So he was like anticipating it well for the discovery of neutrinos. One of the interesting things that I think Professor Kaufman described is the spontaneous polarity changes. In other words, one becomes -1, and -1 spontaneously becomes 1. We don't know why, as neutrino travels at the speed of light, why it happens. Well, I will hypothesize about it, but most science paper says enigmatic particles with the spontaneous morphisms, and there is a lot of mystery about it. So again, maybe some ideas expressed already here may solve that mystery. If we inject neutrino into the lattice, we already know that electron-positron pair grabs a neutrino, electron neutrino at least, into a possibly forming a more involved lattice than iodine salt, but a quasi-crystal lattice. In other words, I'm talking now about not electron-positron pairs that are basic elements of the lattice, but the electron, positron, and in the middle is neutrino or anti-neutrino, depending where the positron and electron is. In other words, on one side, let me go. This is obviously the discoverer of quasi-crystal model, and our Israeli Dan Schachman, he got a Nobel Prize this year. And here is the transition into, and here I have, where is the, we don't have a pointer. So,
the front button on your hand, under your thumb.
In my laser pointer?
Yes.
Good. So we have this pair of electrons, and they accept that speed is light, obviously, but some stray away, some lost. This is just another illustration for transformation. I'm trying to show, this is a Wilkinson obviously probe, which shows the background, radiation background. But what I'm trying to say is that the difference in color probably reflect the different patterns of quasi-crystal patterns within the regions of the universe. And we know that they morph, again, they change. If we take the same photograph in 100 years, it would be different. So now I take both a small element of this and take the quasi-physiologic patterns. They're useful in, they have different shapes. And one thing about them is they accept small gaps, but they are naturally form some structure. Now, when we have patterns that change, and we have an agent of change, which is, let's say, Majorana particles, not necessarily neutrino, we have all that. Then we can theoretically, now I'm shifting, I don't want to go too far into metaphysics, but we have a material to script, which is our lattice. And we have a tool to script, we have a pen, and we have the theoretical, now it's hypothetical. We have a capability to change the information, to record information, to affect or talk between different areas of the universe by scripting the information in a form of different patterns. By, again, exchange of the Majorana particles and changing them. And for that, what is important is to have free energy. Free energy, nothing is free in this world. So again, I'm talking about C, Dirac Sea, affecting. Let's go back very quickly. Okay, I'm talking about the Dirac Sea affecting the quasi-crystal lattice. In other words, we need the energy in order to our artificial brain, or you can say it's a computer, you can say it's universal intelligence, I don't care. But in order for the process to occur, we need an influx of energy. Now, the universe is finite. That's most of the scientists agree that it's finite. In other words, the whole thing is finite. So the energy, as we grow our quasi-crystal universe, it goes away. We run out of energy at some point. And here I'm talking about possibility that universe at some point started to intentionally and actively recombine itself. In other words, there are several books of now popular to describe universe as something that has some thinking computer component in it, but cosmic mind or whatever. But nobody tried to explain how physically it could be done, and I here show one of the hypotheses of how it can happen. What happened in our evolution is that about 2.2 million years ago, there are relatively several types of monkeys, doesn't matter. All of a sudden, they started to think. In other words, from some primitive thinking, and with that, the brain size increased from 600 grams in a humanoid monkey to 1 kilogram to 150 grams today. In other words, it kind of reflects what I'm talking about universe. When it grows, this rapid acceleration may reflect the growing ability to produce information or exchange information between its parts. Some sort of thinking process. Again, probably more computer-like than human-like, but it is very, and then it would obviously, it may repeat our processes in our development, which go from Hebbian stimulation. I go into the psychology, human psychology, which I don't want to go too far because the group here is mostly physicists. But I'm saying that the lattice that I described may gain intelligence, becoming a self-booting, self-learning, and self-scripting supercomputer. And this idea is reflected in this book, but the gentleman who wrote it, he's a computer programmer, and he didn't come up with the instruments of change. In other words, he didn't say why it would self-write, on what, with what tools. And I here suggest the tools for the writing instrument, the writing part, the language, and the set of symbols. And here I go into the grammar and explain how the linkages of the basic linkages of the quasi-crystal, which is electron, neutrino, positron, how they can be here XA, and how they go into the, by going into the more complicated quasi-components here, they give us a grammar. In other words, if you, this is Chomsky, who is a founder of linguistics, basically contemporary linguistics. I don't like him personally, but and what his theory is accepted universally. So we have to go by that. What I'm saying is that the quasi-crystal lattice of the ether is maybe a scripted language, and now we have all the elements which allow the transformation of knowledge between one part of the universe by another. Here I would I don't wanna go too far.
You have 25 minutes.
Huh?
25 minutes.
I know. I still don't want to go into grammar. Who is interested in grammar? The point is that the grammar here can be reflected by a binary code or a system of qubits. In other words, your description of morphism from +1 to -1 may be written as 1 and 0, and then we have a binary code. Or it could be again a system of qubits, because we have 8 qubits of quasicrystals. So there are several ways again of having
For strings of symbols for that.
strings of symbols. Yes, yes, absolutely. And here I tried even to write something that what is it? Counter-unionization. Yeah, one of the strings that you just mentioned, as how it becomes a code, basically, computer code. Now, why would the universe do that? Some cataclysms affect obviously big areas of the universe, and the universe may look for tools to defend the areas of cataclysm or predict cataclysms. We have an instinct of self-preservation, so that instinct may be typical also for the universe. But we come to a problem here. It also reflects the ways the intellect may develop, which is not that important, because we come to a point, to a little contradiction. Here we have a universe who is fixed on self-preservation. Let's say if it's a supercomputer which has a which is an artificial intelligence, then it will try to prolong its life, make it healthier, longer, happier, whatever. But Vigier development, again, in psychology, I'm not the topic of this lecture, but and it develops abstract thinking. It's big enough, it's complicated enough, it's billions of times bigger than our brain, and trillions of times the activity is more intense. So everything looks good here, but this is what is it, the Jackson column. It's abstract thinking. I reflect it as an abstract thing. And this is just event forecasting based on Pavlovian theory, Pavlovian tactic. It's again psychology, but we have we think that I think it's more like a computer than something more exotic and supernatural. But there is a problem again. If the theory, if the task of the supercomputer is to preserve itself, expand itself, make itself smart and everything else, why would it draw the energy and in a greater and greater amount to expand it when the energy is finite? In other words, the crystal in the middle draining the Dirac Sea for no reason, because at some point it will freeze. When the energy is gone, we all know that because of the entropy, expanding the universe will freeze. That's a given fact. Hundreds of work on that. We are going toward the death of the universe, unfortunately. And I'm trying to visualize why, if there is a universal intelligence, why would it try to kill itself? Okay, and to a strange conclusion that if quasicrystals morph, okay, let me rephrase myself. If the exchange of quasicrystals, changing their shapes, becomes an obsession, like a computer game, like a Tetris. That's what the universe seems to be doing. It's playing Tetris of some sort. In other words, it's more complicated because it has 8 figures, not, but it building where the task is to build a structure where there are no holes or minimum holes, and everything goes together, and you, like a child with a Lego, manipulate the elements to build something. But by building it, the structure, you are running out of your building material. So the gaming process, so it becomes a gaming. The gaming is addictive. So my hypothesis is that the universal intelligence may got addicted to the game, playing itself to extinction. And here I describe the game. And if you look again at the game, it's very similar to 3D Tetris. I don't know if you played, there's 2D Tetris and there's 3D. But it's very similar, though it's more complicated game. And what we see now is a universe which transforms itself into, because it keeps gaming. Today's universe is not the same as tomorrow's universe. In other words, it reflects the ship of Theseus, Plutarchian concept, where the ship, if you change all the elements on it, it's a different ship at some point. Was for addiction. We don't know why people get addicted, and we don't know if actually, again, it's what I give you is a hypothesis, very strange hypothesis. But what I'm saying is, if you start with the Dirac Sea, which is quite accepted hypothesis, and keep going through the crystal lattice, quasi-crystal lattice, and further into the development of gaming, you come to the conclusion that universe is playing a game which is self-destructing in the final analysis. So, game description. Here I again describe the rules of the game, but the important part is it keeps recombining shapes. In other words, it keeps building and rebuilding itself with the use of energy which is not, the amount of which is finite. In other words, when all the positrons and electrons of the Dirac Sea, which is chaotic structure around the crystal, when they all annihilate each other, and all the neutrinos are drawn into the crystal, the entropy leads to death, to freedom. In other words, I have here a bit of this is the rules of the game. Here's typical game's dilemma: why to destruct or not to destruct. And here is a little quote from a film that I've seen, an old Woody Allen film. Doctor in Brooklyn, why are you depressed, Alvy? Alvy at night. And so it's played by a different actor than Woody Allen. The universe is expanding, and if it's expanding, someday it will break apart, and that would be the end of everything. So Woody Allen. Harvey is Woody Allen, remember. He always depressed, he has all these complexes. He stopped doing his work, homework, she complains to a doctor. And the doctor and Harvey, who is Woody Allen, says, what's the point of doing homework if the whole thing will die away sometime in the future? And because it's expanding, and expansion leads to freeze, to that leads to universe will freeze and then break apart. Anyway, and Alice Mom says, you are here in Brooklyn. Brooklyn is not expanding, which is true. The galaxies fly away from each other, but Brooklyn remains the same in size, if you measure. So she apparently is trying to convince her son that don't worry, maybe you're wrong. And so I try to find a little bit of positive note in my presentation. Okay, I think that's it. And we have plenty of time for questions. Actually, any questions?
No question.
So this depends on it being a Majorana neutrino. If there aren't Majorana neutrinos,
yes,
then this whole concept isn't valid. So it depends on there being Majorana neutrinos.
Yes.
Which we don't know yet. We don't know whether they are or not.
No.
Yeah.
It's there is a Majorana.
Yeah.
Who is it here? Tori Majorana. It's a particle.
Yes.
And so he predicted the existence of
yes,
neutrino.
I understand.
But neutrino we already, it's proven that neutrino exists. We said that, remember the experiment, recent experiment from CERN to Italian lab.
Which is blown. I mean, that experiment's blown.
No. The outcome of the experiment where they showed that it exceeds the speed of light, that was wrong, but that particle exists. So
indeed,
it just travels at the speed of
my
light.
colleagues work on neutrinos, but we don't yet know whether they're Majorana. So this theory does depend on that being established.
No, it's established because when they send neutrinos,
Yes, I know about
they don't, when they derive their location, they change their polarity often. So that's the description.
I thought that was not established.
I thought it's established at least.
Not that they change into their own antiparticles, which is what they would do if they're Majorana neutrinos.
They are their own antiparticles. They are opaque. The spin direction, it's the same particle, but they change the rotation.
I think we're still waiting experimental confirmation. But
Okay, Wikipedia says it's
okay.
Let me make a comment. 2 years ago, or maybe 2 years ago, John asked me, could the Apollo of Simone not be a face-centered cubic lattice polycrystal, but could it be a ceramic? And what it sounds like is what Boris is talking about is almost a ceramic structure. Do you remember asking that?
Yes, I think I said you were more.
Amorphous, that was it. And I was saying no, because it's not the lowest energy state. But that might solve your problems, or not the dilemma.
Another question back there.
Boris, you went very quickly. You were showing one exhibit of the quasi-qubits construct. You went very quickly. I didn't see the other geometric models. Could you go back to that in your presentation? You should quickly when there's some very important exhibits in terms of your lattice work. One of your exhibits back to
I can, but if you Google quasi-crystal, it shows all the figures that.
how many basic forms were there in that schema that you were showing?
Yeah, can you actually go back to
Yes, I can.
And which of those which you support is a dominant trigger?
Isn't this yours here?
In crystallized
presentation.
moments?
It's that? Okay.
Yeah, looking forward.
Yeah, you can
Yes.
open that.
Don't cancel it.
No, don't cancel it.
Where's my slides?
You just closed it.
Press escape to come out.
Okay, I escaped, and it's a previous presentation. That's
Yeah, you
Go
can
down
close
the
that
slide.
down. Close that down. It's the
pulled
thing.
it down.
Yeah, with the red button.
Yeah, okay, I close it.
No, well, it doesn't matter.
Okay.
Okay, and here I am still not in my.
Go to
Let's
start.
yeah. This is
No,
this
that's
is
the wrong
my-
presentation.
Go to my computer.
My
I'm starting.
computer.
Yeah, no,
My computer. My computer.
Down my computer to there, right there. Click on that.
Okay, and I'm looking for
Now
my
double
memory
click on
is
your,
here.
yeah, double click it.
I know.
Okay.
And here is we don't need medical disability, we need presentation.
Good.
Just a second.
Roll call the same.
Where right here, I think.
So that's the trouble. They've all got the same name.
That's not best for you.
That was
Okay.
Close the PDF file right.
slide sorter.
Yeah, just go click on behind that.
Yeah, let me see. I think it says best presentation. Here. I think I would be able to, with a different file, show you the quasi-crystal recombination. This is probably answers your question about the shapes, quasi-crystal shapes, how they morph. And that's the...
Yeah, that's a
Well, that's
monkey.
just-
Does that answer your question?
The tesseract.
I wanted you to emphasize what you felt in your own logic, which would be more of a dominant form of the crystal unfoldment. We're looking at
Okay. Yeah, and this is also, by the way, quasi-crystal animation. It shows the morphism process, which is very similar to what you see in, it's called not kaleidoscope, teleidoscope, when you rotate, but it's the same principle. It has a set number of figures, and they morph just like that. So, I guess that also answers a little bit to your question, but let's go back to...
Just go back to the original presentation.
Yeah, I know, I'm
It's
looking...
behind you.
You're in
behind
it.
it. You're in it.
Click on behind.
Click a
Go
bit
down
lower.
below.
Close that window up at that.
No, not that.
Just watch the screen. Just touch the screen behind that.
The word Dirac.
Go out of the box.
Put the pointer out of that
Think
box now.
outside the box.
Outside the window.
Okay, I'm not ready. Where is my... yeah. Let's go, I will go back that way. It doesn't go.
Go the other way then.
No, forward.
So it's only forward, it doesn't go back, okay.
You're back all the way.
Okay. Okay, here is maybe three-particle transformation. How it builds different figures. That's a quasi-crystals. How they are geometrically occur.
Nature magazine had a special article a few years ago on how that hero model was one they thought was
Here is a structure, for example.
a very interesting model process. Can you continue? Just scroll down.
Okay. But this blue ornament is what Sheffman wear on his tie during the another ornament. Oh, that one is a from the crystal transition into a more complex quasi-crystals. In other words, that's normal evolution process as I see it for the...
Yeah, it doesn't matter now because you might have T and that's it.
No, that's about it, I think. Pavlovian draw. This is Tetris, but again, I just showed that it's a very similar game, basically. Building your Lego from Tetris figure. Those are also quasi-crystals, and they obviously three-dimensional figures that More similar actually not to a Tetris but a children's computer, for a children's magnetic game. This is a, it's sold commercially as a magnetic, you can build the components into clusters from these basic figures. And you can also transform the figures. Maybe that. Yeah. But if you go to again to Project Crystal in Wikipedia, you will find plenty of information. There are hundreds of descriptions of the how they morph and how they occur in nature and in different chemical.
Okay.
So we're looking at multi-lattice constructs that are very complicated, but very simplistic. I mean, that's a very, very unique, pluralistic model building
Yes,
that we're facing.
and the important thing is that it has practically no gaps. In other words, it goes together, so it allows the, let's say, particle or photon to go from one end of the universe to another without stoppage because it has no, there are little holes of probably false vacuum. I don't know exactly. I'm not sure.